Good morning, dear students, and welcome back to this part 4 of electrolysis. In the previous video, we already completed about that characteristics of electrolysis and the mechanism of electrolysis. Now, in this video, I am going to discuss that some examples of electrolysis. So, let's start. What are the examples of electrolysis? The first example is electrolysis of lead bromide. Okay, that is molten lead bromide. So during the process of electrolysis, you have to remember that three things. The three main things are what are the electrodes you are using, that means what are the cathode and anode, that may be active electrode or inert electrode. Okay, and the second thing, what is the electrolyte you are using and what is the reaction at cathode and what is the reaction at anode. So let's see here that electrolysis of molten lead bromide. Lead bromide, that is PbBr2. Okay. So here two electrodes you are using, that is cathode and anode. Cathode is made up of carbon and also that anode is also made up of carbon. That means both the electrodes are here inert. That means they do not take part in that electrolytic reaction. Okay. And the electrolyte here is what? Molten lead bromide. That means PbBr2. When you give the temperature, it starts to melt and it dissociates into Pb2 plus and Br minus. That means what are the ions present here? Pb2 plus and Br minus. That means as we know that that positive ion, okay, they migrate towards cathode and the negative ion migrate towards anode. So here that positive, when you give the temperature, that electrolyte, that is PbBr2, it starts to melt and form that what? It dissociate into Pb2 plus, which will be migrate towards cathode and then neutralize, okay, and form what? Pb. And the Br minus, that is migrate towards anode and then neutralize to Br, okay. That means see here, what is the reaction at cathode and anode? That means see here, at cathode, that Pb2 plus migrate towards cathode and here gain 2 electrons and neutralize to Pb, that means lead metal, okay. And that at anode, what happened? That Br minus, it will be lose that electrons and form that what? Bromide, okay. That means Br, and this 2, that means it lose 2 electrons. That means these 2 electrons combine and form that what? Bromine molecules. So what happened? That at cathode it gain 2 electrons. That means that reduction will be take place. That means that cathode reduction reaction will take place, and at anode oxidation, because it lose that 2 electrons and form that oxidation. So what we observe here? That means at anode, okay, that bromine gas will be evolved, and at cathode, that is the lead metal will form, that is Pb, okay. So this is all our what? That electrolysis of molten lead bromide, okay. At cathode always what? Reduction will take place, and at anode oxidation will be take place. And what is the product form at cathode and anode? So what you say? That at anode we get that what? Bromine, that is Br, okay, and at cathode the product form is that lead metal, that is Pb, okay. Then next we move to that that electrolysis of acidified water, okay. Here also that same process, see, that is that process of electrolysis of water. Here what happened? 2 electrodes you are taken, that is what? It is made up of what? Platinum, okay. That is here what? Inert electrode, that means they do not take part in that electrolytic reaction. And what is the electrolyte? That is acidified water, that means water plus dilute H2SO4. That means what are the electrolyte? Water plus dilute sulfuric acid, okay. So here dilute sulfuric acid, so it will be dissociate H2SO4 and form that what? H2H plus plus SO4 minus, and water H2O, as we know that it dissociate into H plus plus OH minus, okay. So now what are the ions present here? That means H plus plus 2H plus SO4 minus and OH minus. So here what happened that what is the reaction at cathode and what is the reaction at anode? See that the equation at cathode, as we know that what are the here what happened, two positive ions will be found, that is H plus plus 2H plus. Okay, so this H plus will be, that means same, that means H plus will be migrate towards that cathode. Okay, and here what happened, it gained the electrons and neutralized to what, hydrogen gas. So at cathode what happened, reduction reaction take place and what product will be formed, here hydrogen gas will be produced. Now this two anion, that is SO4 2 minus and OH minus, what happened, this out of these two anions you have to select one, which one will be readily dissociates. That means what, you know that hydroxide will be lower at that electrochemical series, so it will be reduced easily. So hydroxide will be migrate towards anode and there it will be neutralized in the form of oxygen gas. Clear? That means what? When that hydroxide moved towards migrate and there what happened? It lose the electron and form what? Water plus nascent oxygen. And when you will be multiply by this 2, what you will be get? That is OH plus OH 2 electrons are there. That means it will multiply that. That means 4 OH. It gives to water plus oxygen molecule. That means at anode oxygen gas will be reduced. That means oxidation reaction will be take place at anode and at cathode reduction reaction will be take place. That means what you find? What is the product form at cathode and what is the product form of anode? That means at cathode it will hydrogen gas is produced and at anode oxygen gas is produced. This is all about what? Electrolysis of acidified water. Now I move to what? Electrolysis of copper sulfate solution, where that what, platinum, okay, is an electrode. That means inert electrode. Okay. So here you see what are the electrode you are taken, that is both the cathode or anode are what? Platinum, that means inert electrode. And what is the electrolyte? Electrolyte is what? That is aqueous solution of copper sulfate. That means what? CuSO4 plus water. Okay. So what are the ion dissociate? You know that copper sulfate. Copper sulfate it dissociate into what? Cu2 plus SO4 2 minus. And water dissociate into H plus plus OH minus. So here two positive ions and two negative ions are formed. Okay. See here, what are the two ions? Cu2 positive ions are Cu2 plus and H plus and negative ions are SO4 minus and OH minus. So now I have to discuss that, as we know that electrodes are what? Inert electrodes. They do not take part in that electrolytic reaction. So you have to choose one cation and one anion which will be dissociates. Okay. So here out of these two positive cation Cu2 plus and H plus, as we know that what? Cu2 plus readily dissociate into ions and Cu2 plus what? Lower in that electrochemical series. So Cu2 plus will be migrate towards the cathode and here what happen? It will be neutralized to Cu, okay, that is copper. Okay. And that at anode what is the reaction? That is sulfate SO4 2 minus and OH minus. Here what happen? Hydroxide will be reduced. Okay. That means hydroxide will be migrate towards anode and it neutralize in the form of oxygen. So at cathode it form copper and at anode oxygen gas will be replaced. That means at cathode reduction reaction will be take place and at anode oxidation will be take place. So what happened when the deposition of copper ions is completed after, because see here what, copper is produced at cathode. So when it is completed, the electrolysis of water take place and the hydrogen gas is liberated at cathode and an oxygen gas is liberated at anode. When after complete that copper ions. Okay. Now we have to move that electrolysis of aqueous copper sulfate. That when that electrodes are active, that means you have to take that the two cathodes must be in copper. Okay. That means copper electrode. That means they are what? Active electrode, and they take part in that electrochemical reaction. Okay. So see here two electrodes are there, and both the cathode and anode are what? Copper. That means active electrode. Okay. And what is that electrolytic solution? Here electrolytic solution are copper sulfate plus water. So copper sulfate dissociate into Cu2 plus SO4 minus, and water will be dissociate into H plus OH minus. So now what is the reaction at cathode and what is the reaction at anode? See here, as we know that copper is that electrode, active electrode. Okay, so here reaction at cathode, as we know that here also two positive ions are formed, that is Cu2 plus H plus, and two negative ions, that is SO4 2 minus plus OH minus. So at cathode, see, copper 2 plus 2 electron, out of this what? Copper 2 plus ions is discharged. Okay, and it will be gain that electrons, and what happen? It will be neutralized to Cu. See that equation, Cu2 plus it gain 2 electrons and form that copper metal. Okay, but at anode, as we know that what? The two anions are there, that is OH minus and SO4 2 minus. Both are not discharged. Why? Because this copper, this electrode is an active electrode which are take part in that electrolytic reaction. Okay, so what happened here? Copper will be it will be lose the two electrons and form what? Cu. Okay, so what you find here? That means the electrolytic aqueous copper sulfate may be acidified, which will be remain same. Okay, and that electrolytic solution also will be not changed, as we know that copper sulfate blue in color, that will be remaining same. That means its color will be remaining blue in color. Okay, because the presence of copper. Okay, so these are the what? All about that electrolysis of copper sulfate solution when the electrodes are active electrode. Okay, so with this, these are all are that what? Examples of electrolysis. Thank you.